no matter where there's a very big ROI coming out of these investments on smart manufacturing. Where will a factory be located? Actually depends on various kind of factors. Labor cost is one, but it's definitely not the top one.
Hello and welcome to Move Conversations. This is your host, Venkat. In this episode, we will be speaking to Mr. Koen De Backer, VP of Smart Manufacturing and Artificial Intelligence at Micron. He's also chairman of Semicon Southeast Asia, an industry association. He's responsible for driving Micron's smart manufacturing initiatives, digital operations, including capabilities with IoT, artificial intelligence, advanced analytics, cognitive computing, and machine learning, and essentially all of these to enhance business, global operations, and product development. Prior to joining Micron, Mr. De Backer was a partner at McKinsey & Company, where he steered the semiconductor consulting practice in Southeast Asia, and one of the firm's leading experts on applying artificial intelligence and automation techniques across operations, support functions such as finance, human resources, and procurement. In this conversation, we will be talking about smart manufacturing and use of AI in semiconductor industry. Welcome to Move Conversations, Koen.
Thanks a lot, Venkat. Thanks for having me.
Our pleasure having you. So let's kick off with a very simple question for people who would like to understand what the context of the discussion, the theme of the topic, theme of the discussion. What is smart manufacturing?
Yeah, so smart manufacturing or Industry 4.0 is basically nothing else than a whole suite of digital technologies that we try to apply to manufacturing to improve the efficiency, right? And that's a broad range of different sort of digital technologies. Think of it, on the one hand, it goes from mobile applications, augmented reality, virtual reality type of solutions, to physical physical automation solutions like robotics, etc. To more data science, machine learning type of solutions, or IoT solutions, where we're capturing more data from all of the tools and all the equipment that we have in the line. So it's a very broad range, and it's actually very open-ended in the sense that every time there's new technologies, things of blockchain, for example, we will constantly evaluate that is it mature enough and is it applicable for us to actually go and apply this in manufacturing or not.
Right. So you referred to sort of Industry 4.0 framework in your opening remarks. So smart manufacturing and the Industry 4.0, how are they deployed in the semiconductor industry in particular?
Yeah, if you look at semiconductor manufacturing, you basically have like two main components of it. You have the front-end wafer manufacturing, that's going from a bare silicon wafer all the way to imprinted logic on the wafer itself. That's what we call front-end manufacturing. And then you have assembly and test, which takes that wafer and basically dices it up in individual dies and then later on components that then get packaged into individual chips. And if you think at these two areas, like the front-end area is highly, highly automated. These are the most advanced factories in the world that you will find. Here in Singapore, we have quite a bit of semiconductor industry, including Micron, where I work now. And those are, since many, many years, are almost fully automated. So they have automatic material handling that brings all of that moves the material in between the different processing steps, etc. There's still labor involved, but that's more from a technician perspective, for example. And when you move to assembly and test, the level of automation is a bit less compared to what we have on the front-end side, but over the last couple of years has increased dramatically as well. So what that means is, if you have a very high level of physical automation, it means that you can really start working on data science-based solutions because you've got tons of data available in a very reliable way. And the data is huge, right? So every day we get about 13 terabytes of new data of our equipment on the front-end side. We measure 500 million of sensors in the line across all facilities, etc. So it's that sort of magnitude. And so what it then means to do smart manufacturing on that is basically to help our engineers to make better decisions, right? And so a lot of in semiconductor industry, a lot of smart manufacturing is really done on the data science analytics piece, where we're basically trying to predict or prevent any sort of excursion happening. So we try to control the quality to the best extent. We ramp our newest generation of products in a faster and faster speed. So that basically means the latest generation of NAND products, so storage products or DRAM products, they come on the market in an ever faster pace. And every new generation comes with kind of higher performance, comes at a better unit cost, etc. So there's a huge benefit that automotive customers and others are getting from that. So overall, the semiconductor industry was already very automated, and what Industry 4.0 and smart manufacturing does is really add a new layer of it, of intelligence, based on all the data that we captured throughout the line.
Right. So, we often hear terms like robotic process automation, IoT platforms, machine learning, AI, a whole series of things. But how are you using these in semiconductor and related industries also? Sort of spread it to that.
I mean, maybe kind of just to give you a bit of a suite of or different types of solutions that get deployed. Maybe a very simple range of solutions is everything to do with labor productivity solutions. When you think, for example, of a very automated factory already, where do you then further drive labor productivity, right?
Exactly.
Well, first of all, is you still have technicians in the line. You still need to do maintenance. So what we do there is we drive a lot of mobile applications. So the same way you will book your Grab app, for example, is exactly the same way of our technicians will see all the different maintenance jobs that are needed, and they will grab that specific maintenance job and basically get allocated these and execute these maintenance tasks. That's like one example of it. Robotic process automation is helping in the day-to-day work of many of our engineers. There's still a lot of repetitive work that they need to do in engineering type of work. And we basically enable them with tools like robotic process automation, which is nothing else than kind of a more intelligent version of our typical macros that we used to see in Excel, for example, right? So how do you do like a recording of the different activities that you do? So you can basically have kind of your machine, your laptop, basically take that over from you. So these are a simple range of labor productivity type of solutions. But kind of another suite of solutions for us is really kind of everything to do with machine learning type of solutions. And a big area in there is everything to do with image analytics. Throughout the manufacturing line, in our front end, it's about 1,500 production steps that you go through. And you can actually take an image of that wafer throughout the production steps. So you can actually then compare these different images, and you can see based on the patterns that you see throughout, you can then start to identify where there's a deviation that happens or any sort of improvement that you can make. And so these are the typical sort of image analytics that gets done in a semiconductor industry. Other areas where we focus a lot on, for example, is everything to do with simulations, planning simulations. Think of it from a perspective, in a semiconductor industry, you spend a lot of money on the newest and latest equipment. So every couple of years, for the next generation of products that you bring on the market, you need new generation of products from companies like ASML, Lambers Research, and AMAT, etc. And these are hugely expensive tools, some even more than $100 million for one piece of equipment. And so you need to get the maximum efficiency out of that. And you do that, for example, everything to do with planning simulations. How do you schedule all these different production steps in the most efficient way? That's a very big area as well. So overall, I would say, if you think of it like the different sort of technologies, they either focus on ramping your products faster and bringing that faster to the market. It is based on how do you use your equipment and your CapEx that you invest in the most efficient way. It focuses on the controlling quality in the line, and it focuses on overall labor productivity as a overall team throughout the entire manufacturing.
So when you spend that kind of money, even in a tool itself, right, the huge numbers, the question that comes to my mind is, have there been significant productivity gains in adopting all this, Industry 4.0 technologies?
Yeah, for sure. I mean, We do invest heavily in that. For example, in Micron, to give you also a bit of a background, we currently across the network, we have more than 600 data scientists, data engineers, solution architects that are dedicated to driving these smart manufacturing efforts. Of course, that is something that not all companies can afford. I mean, and it's also not needed for every company to do that. But when you are in an industry like in semicon industry and you focus on these sort of very advanced type of applications in manufacturing, that's where we can really make a difference, right? And so hence why there's so much of a push in investing in that. So where do you see these investments pay off is really in better availability and utilization of your equipment, right? Like you see an increase, although it is already high traditionally, you can see with these new techniques, you get a couple % improvement in terms of availability, which is a huge dollar value because that really translates in higher output out of these factories. You also get a faster ramp of your technology. So every time you bring a new technology in play, you basically need to ramp the yield to a mature level. And the faster you can do that, using a lot of the machine learning, auto diagnostic type of technologies that help our engineers, you're able to do that faster and you bring that latest technology to the market. Every new generation comes at a higher performance at much lower cost. So that's actually quite unique to a semiconductor industry. It's better for our customers and it's better for us because at a lower cost point. So it's all about pushing the boundary for next generation products. And so there's a huge benefit in there in being ahead of competitors there. And Micron, both on the NAND side and on the DRAM side, is driving that technology leadership. And that is very, very important in our industry. So hence why we invest so much into that. I would say overall, anything to do with planning, etc., has two elements to it. One is, again, maximizing the output out of our factory by just making sure that throughout these 1,500 production steps, we're able to maximize as much as possible the output. But at the same time, also cycle time. So cycle time meaning kind of how fast you can get through all of these production steps. And depending on what product you're looking in our semiconductor manufacturing, you're looking at in front end anything between 80 to 100 days of cycle times. And then you have like a assembly and test. You have another 10 to 20 days of cycle time there. So it's very long set of production that you need to go through. And of course, anything that you can accelerate there translates again in getting faster to market with your product.
So these have been very beneficial for you. Then the question that I have is, for last few years, there also been a talk about the digital twin concepts. Right? Do you guys use this in your industry, and how beneficial is that?
Yeah, so digital twin, there's many versions of it. So in the most pure form, what a digital twin is in itself is almost a visual representation of your factory, right, of your flow, and then using real-time operational metrics in there to be able to do simulations, etc. For Micron itself, we can actually focus on two different types of digital twins. One is on process digital twins. So individual processes within our manufacturing. How do you do simulations there without having to physically run design of experiments, right? So that you basically simulate how the process would run and basically try to understand how the different parameters work together to optimize processes and recipes. Because that helps us to reduce kind of the amount of physical tests we need to do, speeds it up, but also costs less overall. And then on the other hand, we do what is called planning digital twins. Is the planning and scheduling of which lot can run in the line is a very complicated thing with more than 1,500 production steps, many interdependencies in between in terms of how much time a lot can spend in between, etc. So there's a very high complexity there. So we call that our planning digital twin, which is basically a virtual representation of our factory. It's not so much visual, but much more of an overall complex network of individual nodes, where then linear programming optimization happens to basically and combined with things like, say, for example, reinforcement learning, to try to find kind of the optimal way of moving the lots through the line, taking into account cycle time, output, etc., etc. So these are some practical examples of where we use digital twin technologies, and they're mainly used for us out of a simulation perspective. Try to simulate what the physical reality looks like. We get a lot of insights out of that, and a lot of optimization comes from that.
So your app uses, if I understood correctly, is a bit different from power plants or jet engines who may be able to take data from performance and then compare it with different machines and things.
So there's definitely a linkage to the like say, for example, our planning digital twin will take kind of the real-time operational data and take snapshots of everything that runs in the line, and then we'll real-time try to kind of optimize the scheduling. So it always has that linkage to kind of like what the real-time operational metrics are, similarly for process digital twins. But yeah, what is the main difference, like with what people typically look at as digital twins, is really traditional digital twins are really the visual representation either of the product itself or of the manufacturing flow itself. And that's actually less the case for us. But the same kind of principles apply to take that operational data and then do the simulations and in parallel to the physical world.
Right. So the other technologies which you have not spoken till now is augmented reality and virtual reality technologies. Where do you use them in semiconductor manufacturing?
So augmented reality is actually a very interesting area. If you think about it, pre-COVID, I think many people would have looked already at that, and we also did at that point of time. But it was at that point still small scale type of pilots, interesting technology. Everybody likes this, right? Like everybody can imagine this is something cool to do. But it became real during COVID, right? So all of a sudden, we couldn't have our equipment suppliers travel to our sites anymore to do new tool installs or to help with the troubleshooting. Or we were not able to get some of our experts that located in other factories to move to certain factories to help. So all of a sudden, the investments that we did before had to be scaled very, very quickly because this was reality, right? Like we had to install new tools. Our factories run 24 hours and they never stop. So you have to do that in order to install these latest generation of technology, of equipment. And for any sort of troubleshooting, you basically now have the opportunity to remotely dial in an expert that sits wherever in the world. And even now, post-COVID, or in kind of at least a time where we can travel again, it does still have like significant benefits because it's much faster, right? You don't need to wait until the expert is actually on site. You can immediately kind of connect anybody into the site. And we go a step further in that one as well, like focusing more in other areas. Say, for example, now more and more, you hear a lot of construction that happens in semiconductor sites, etc. So the area where we focus now with augmented reality is also develop it in such a way that if you want to explain to contractors what they need to build, it's so much easier to let them show how it would look like in 3D versus on a 2D drawing, right? Like a 2D drawing is hard to interpret. The 3D visualization is so much easier. So you reduce a lot of rework as a result of that one. You make it first time right. So that's really on the augmented reality piece. Virtual reality, it's different headsets, right? Like it's more for training purposes itself. We're a bit earlier in that kind of, it's still in the phase like where we're trying to ramp that up. We do see significant benefits for that already. We can typically develop in a 2-week time period. We can actually develop like new trainings. So it is significant investment to kind of convert a lot of our trainings towards more virtual enabled, virtual reality enabled ones. And we focus it a lot on areas where for safety training, for example, like if it is confined spaces or it's kind of, electric charge type of areas, you don't want to have people go in there. You want to train them first through a virtual reality training. And for other activities as well, for our manufacturing, for the more complex type of operations, traditionally we would bring them immediately into the factory and train them on the floor itself. Now we try to do that more and more, first through virtual reality, and then later on bring them on the shop floor. So it speeds up the training cycle, actually.
Yeah, yeah. You mentioned at the start of it, rightly, that semiconductor industry is already highly automated industry. So what is, so for your industry, what does future of automation look like? You guys are already at, compared to many other industry, you probably are the future for them. But then where are you guys, where do you see your industry's future?
For sure. Well, I think this, as I mentioned, front-end manufacturing is highly automated. Assembly and test has become more and more automated. There's a lot of flexible automation, kind of combination with AGVs and flexible robots that gets deployed there more and more to replace some of the kind of loading, unloading that happens. And so there's more and more happening there. And I think that's a really exciting journey. But even in the areas in say, for example, front-end manufacturing, there's still ongoing innovations. Say, for example, tools like these very expensive pieces of equipment, more and more they get equipped as well with capabilities for self-maintenance, so that, you know, if they need to change out a part, they have spare parts as part of the overall kind of storage within the equipment itself. And these tools can swap it out automatically, because
that's interesting.
Yeah, so all geared towards making sure that, you know, the uptime of these machines is as high as possible. So where it makes sense, like it's more like looking at these sort of specialized types or areas of automation. But where our biggest focus is at this point in time is really on the engineering side, right? So not so much on the physical automation, because there's obviously a lot that has been done already, but it is, how do you make sure that you do the automation that for the areas that, you know, can't get physically automated, or anyway, where we have like a lot of engineering brain power that is needed, on how do we kind of help to automate tasks and kind of drive more intelligence that a human being can't do just because there's too many variables to look at. So that's our key focus from an automation perspective. From a pure dollar value, labor productivity is not the biggest area for us to focus on. It is the benefit you get out of it from a perspective of bring the latest generation product to the market, etc. So it's helping our highly educated workforce to be more efficient. That's the level of automation that we're trying to go after.
True. So that actually gives me a segue to my follow-up question. That is like, I read the McKinsey estimates, which in your past, I think you also contributed to and wrote about it, that the direct labor cost is only 2%. Industry is highly automated, especially in 300 fabs, and then maybe 10% in 200 fab. You also, the report also mentioned that indirect labor cost may be about 20% or so. Mm-hmm. So the question I have is that, will these labor cost estimates hold when the semiconductor fabs are reshored from Asia to USA to Europe or other friendly nations in the West? And what will be the challenges and cost increases if semiconductor fabs move away from Asia to the West? This is a very topical thing. So I thought,
yeah, for sure. I mean, actually, the drivers behind kind of where will a factory be located actually depends on various kind of factors. Labor cost is one, but it's definitely not the top one, right? Because if that were to be the top driver, we would not see factories at this point in time getting announced in US, for example, being a high cost area. Other drivers play a very big role. Of course, incentives play a big role that all the different governments are contributing to. Availability of water, of renewable energy, and the availability of a talent workforce. Absolutely. These are some of the main drivers that actually kind of make where these factories are located. And actually, if you look at it now, irrespective of factories being based out of US or Europe, etc., even now, like where all our front-end wafer manufacturing locations are what is considered all high-cost geographies. And that is just out of that's where the ecosystem has traditionally been built up. That's where you find the high skills that we require in terms of engineering, etc.
Absolutely.
So yeah, some of the shifts that you see, for sure, they will kind of, drive kind of more push towards, implementing more of these sort of smart manufacturing solutions in our factories, but really not so much from a labor cost perspective. It really drives it more. Every new generation of product as a kind of an additional level of complexity that comes with it. And so it's all about how do you find the right talent in the market that you then can educate from a very technical perspective on our processes itself, and combine that with typical data science type of skills, because that combination really kind of is the differentiator for us. So it's is not as much linked to kind of any shift in like where these factories are located. No matter where we will, there's a very big ROI coming out of these investments on smart manufacturing, and all factories worldwide are pushing that to the maximum extent.
Wonderful. And I think it gives us a great insight into what's happening in your industry, how, you guys are at the cutting edge in deploying, for industry 4.0 technologies, AI technologies, while many others are still trying to understand how it could be relevant, where they could gain productivity, make productivity gains, and so on and so forth. You guys are actually probably the poster child for some of these technologies as to how this can be done and where these can be applied, and so on. I think it was a great insight for me personally, and I'm sure for our audiences. Thank you very much for sharing these insights. And
happy to do, and thank you so much.
Back, different, there could be other things, and this being our first conversation with you, maybe this was the introductory topics. Maybe some other time we could dive deeper into some other.
Yeah, absolutely. Topics. More than happy to do. Thanks so much for having me.
Thank you so much. Thank you for joining us in yet another episode of Move Conversations. Hope you enjoyed this episode. Please subscribe to the Move Conversations YouTube channel and press the bell icon to get notifications of new episodes. Thank you very much. Till I see you in the next episode. Thank you very much. Have a great day.